Okay, so this is a problem where we have a 30 Newton push on a 2 kilogram mass which is resting against a 1 kilogram mass. And we are not going to consider friction in this problem, so the friction is taken to be 0. So first thing to do is to set some coordinate system up. So I'll take y increasing in the upward direction and x increasing in the right direction. And what I have here is a free body diagram for big M. That's the 2 kilogram mass. And then over on the right I have a free body diagram for little m. That's the 1 kilogram mass. So big M, the 2 kilogram mass, has two vertical forces. A downward weight, which as you can see is 20 newtons, and an upward normal force from the floor acting on big M, and two horizontal forces. First of all, the 30 Newton push to the right, but also the force of little m pushing back on big M, which is this force that you see right here. Having done the free body diagram, we can now do a Newton number 2 in the y direction and the x direction. And in the y direction, you can see this logic allows us to conclude that the normal force acting upward from the floor onto big M is 20 newtons. That's the result of setting a sub y equal to 0. You can see the algebra right here. In the x direction, Newton number 2 says that the mass times big M times the acceleration in the x direction is equal to the net force in the x direction, which is equal to the push P minus the force of little m on big M. This force, in other words. Note now when I go over to little m and I do the same thing there, I'm assuming the same a sub x for both. I'm assuming they're both continuing to push against each other and therefore accelerating at the same rate. So the free body diagram for little m is very similar. There are two vertical forces. Using the same logic, we can conclude that the normal force acting from the floor upwards onto little m is equal and opposite to the weight, 10 newtons for little m, and that for the x direction, little m times a sub x is equal to the net force in the x direction, which is simply this force vector from the FBD, the force of big M acting on little m. And so these two forces are a Newton's third law pair. Object and agent have been interchanged. So now if I take my equation right here, m a sub x is equal to P minus this force, and so that's the same thing as subtracting this force right here. But this force can be replaced with ma sub x. And so basically what I get is I get big M times the acceleration in the x direction is equal to the push from the left minus little m times a sub x. I now get all the a sub x terms over on the left. I factor them out, and I conclude that a sub x is equal to the push divided by the total mass. In other words, 30 newtons divided by 3 kgs, which is 10 meters per second per second. Now I can take my a sub x and I can determine what the force of big M on little m and of course what little m on big M is. So this comes out of big M on little m, comes out of this equation right here. So little m is 1 kilogram, a sub x is 10 meters per second, and so this is 10 newtons. And that, of course, means that little m on big M is in the opposite direction, minus 10 newtons, as we have in this picture up here. Now, one insight here is that we could have figured out what the acceleration for this mass system was by ignoring the forces between the masses and just looking at the single external horizontal force, which is the push, 30 newtons, and concluded from Newton number 2 using this perspective that the total mass times the acceleration for the system of these two masses is equal to the single external force, P, A sub x is then P over big M plus little m, 10 meters per second per second. Same conclusion that we reached in this step. Now, an interesting thing to do with this problem is to redo this and switch the position of the two masses. And so you put the 1 kilogram mass on the left and the 2 kilogram mass on the right, and redo this. And I'll let you you guys think about that. But it's a good problem to do. And then the question, if you do that, is what's different, or is it the same?